So I want you to give a try to the next limiting reactant problem. You have magnesium and sodium chloride to make magnesium chloride. Right away, you should notice that that sodium is missing here. You can't have something on the reactant side and not on the product side. So you should be able to identify that it should just be sodium left over because it's a single replacement. So you need a single thing on each side. Then to balance it, you would need a 2 and a 2. What I would like for you to do is to try this problem to figure out how much MgCl2 can be produced. Notice in the problem it doesn't say this is a limiting reactant problem. Okay, so when you have two amounts of reactants, that's indicating that it is limiting reactant. So I want you to try this problem right now. So this is what you should have gotten so far. From the sodium chloride, you would get 1.16 grams of MgCl2, and from the magnesium, you get 2.4 grams of magnesium chloride. So the amount produced would be the 1.16 grams of magnesium chloride. That would indicate that sodium chloride is the limiting reactant. So it produces a smaller amount of your MgCl2. Therefore, the 1.16 is your theoretical value. And then we have Mg is excess. It produces the larger amount of MgCl2. Therefore, 2.4 grams of MgCl2 will never be produced. I guess I should have grams there. Because you're going to run out of your limiting reactant. So then we need to figure out how much Mg is left over. So we'll have to do one more stoich problem. So I would take the 1.16 grams of MgCl2. And we're going to kind of go backwards to figure out how much magnesium is left over. So we'll have grams of MgCl2 on the bottom, moles of MgCl2. It is 95.21. Mole of MgCl2 to moles of Mg. I believe it was a 1-to-1 ratio. If you look at it, it's this reaction going backwards because we're trying to figure out how much Mg is left over. So we'll then go, so it is 1-to-1. And we need one more step to go 1 mole of Mg is 24.35 grams of Mg. So what this number will tell us is how much magnesium was actually used. Which in this case is 0.297 grams. We had 2.4 grams. We used 0.297. So this is a subtraction problem. You do have to be aware of sig figs. We want to round to the tenths place when we do it. And we are going to end up with 2.1 grams of magnesium remaining. So we didn't really use much of our magnesium in this reaction. So 2.1 grams of magnesium remains. Well, actually, that's wrong. Did you catch it? The 2.4 is how much magnesium chloride is produced, not how much magnesium you had to start with. You actually had 0.62 grams. So you're going to take 0.62 grams and minus 0.297 grams. You still have to look at your sig figs carefully, but it's going to be 0.32 grams of magnesium remaining. Sorry about that.